Hello, thank you for checking out A1 Math, and today we're looking at solving systems of linear equations by multiplying first. We will take a look at a couple examples. So basically, in the previous video, we talked about solving system of linear equations by elimination, and how all you had to do is either add or subtract first based on the number being the same. But that's not always possible because the numbers won't always be the same in front of that coefficient there. So what you'll need to do is multiply first, and you have to figure out what to multiply by. So here it gives you an example where you have 2x plus 5y is equal to 9. X minus 3y is equal to 10. So what we want to do is multiply by -2 here. That way, once we multiply by -2, we end up with -2x plus 6y is equal to -20. And now we have that same coefficient in front of the variable with opposite signs so that we can get 0. Okay, let me show you a different example. Okay, now sometimes you'll need to multiply by 2. Multiply by both equations by 2 different numbers so that you can get that same number, because you can't just multiply by 1. Okay, so for this example, it looked at the smallest numbers here, 3 and 2 by the y. And what we want to do is make those the same number. And if you find the least common multiple there, that is going to be 6. So you're going to multiply both of these equations by a number that can make this be 6 and one be -6. So in the example, they multiply the top equation by -2 and multiply the second equation by 3. So once you do that, you end up with -10x, -6y, and -4. And then the last equation here, you got 3 times 4 is 12x, 3 times 2y is 6y, and 3 times 10 is 30. Now when you get ready to add, you end up with a 0 here. And you can solve for x, and then plug it back in. So what I'm going to do is work out a couple of problems so you can see that in action. All right, so here's the first problem. So right away, I'm unable to add and have it cancel out and give me 0. So I need to change it. So the easiest one to change would be this x here. And the way I'm going to do it is kind of like the distributive method. And I'm going to put a -2 here and distribute all the way across here. So I'm going to rewrite that first equation. That's going to give me 2x plus 3y is equal to 5. And then distribute this -2 so that I get -2x, -4y, and +2. And this should be negative. All right, now I'm going to go ahead and add and eliminate the x term, leaving me with a -7y and a +7. Then I'm going to go ahead and divide by -7. That's going to give me y is equal to -1. Alright, so now I have the y, and I just need the x, so I simply just going to plug that back in. And you can plug it into either one. I'm going to pick the second one here. That's going to give me x plus 2 times my y, which is -1, is equal to -1. 2 times -1 here would be x minus 2 is equal to -1. And then add 2 on both sides. X is equal to +1. All right, so now I've got 1 and -1 here, and that's my answer. Let's take a look at another example. So on this one, what we're going to do is take a look and see what can we multiply by to make the easiest thing we can multiply by to change it so we can get one of our variables, either x or y, to cancel out. So I can see how this is 2y here, and that this is just 1y. That's easy to work with, the 1. You just multiply by whatever the other number is you want. So I'm going to multiply by a +2. Okay, I don't need to make it negative because it's already a -y here. So that's going to give me 6x minus 2y is equal to 4. And now I'm just going to rewrite this same equation. Now, when I get ready to add, these are opposites, and they're going to cancel each other out. That's going to leave me with a -2x here, and that's equal to 8. Now I'm going to divide by that -2 so I can solve for x, and x is equal to -4. All right, now I'm going to take the -4 and plug it in to solve for y. I'm going to pick that first equation. And you always want to work with the original equation. So now I'm going to have 3 times -4 minus y is equal to 2. That's going to give me a -12 minus y equal to 2. I'm going to add 12 on both sides. And don't forget, when you have that negative in front of your coefficient, or negative in front of your variable, that's a -1 that you have to divide by. And that way you end up with just y. So y equals -14. So this particular solution is going to be -4, -14. Now, all right, let's take a look at a couple more examples. Okay, now this one doesn't have a coefficient of 1, but you can still multiply by just one number here and not alter everything. So here I'm going to multiply this by -5. And that's going to get me a -10 here, which will add with this positive 10x and cancel out. So I'm going to distribute that -5, and I have -10x minus 25y is equal to 110, -110. So all I did is distribute. Now I'm going to rewrite this equation so that I can add them and eliminate. Alright, now when I add, I'll end up with a 0 here. This will be -22y. And -88 And now I'm going to divide by negative 22. And y is equal to a positive 4. Now, if you didn't see to use negative 5 and decided to multiply this whole equation here by 3 and multiply this whole equation by 5, you should still get the right answer. Even if you decided to multiply, work with the 10 and the 2, you can still get the same answer. But I want to try to keep the numbers as small and as easy to work with as possible. Now that I have y is equal to 4, I'm going to take the 4 and plug it back in. So I have 2x plus 5 times 4 is equal to 22. And remember, always use the original equation. All right, that's going to give me 2x plus 20 is equal to 22. I'm going to subtract 20. And 2x is equal to 2. And divide by 2. X is equal to 1. So my solution is going to be 1, 4. Okay, let's take a look at one more example. All right, now on this one, there's no way of just multiplying by one thing and getting something that's going to eliminate. So on this one, what we're going to do is we're going to multiply both equations here. So I like to work with the smallest numbers and find the least common denominator here. And that's going to be working with 2 and negative 3 here. And the common denominator is going to be 6. So we want to make this a positive 6y and a negative 6y. Okay? And once we do that, we can add and eliminate. So to get this to be a 6y here, since it's positive, I'm going to leave it positive here. To get this to be 6, I have to multiply this whole equation by 3. And to get this to be negative 6y, I got to multiply this whole equation by 2. So once I do that, I have 3 times 4, which would be 12x. 3 times 2 will be that 6y we wanted. And 3 times 14 will be 42. And then next, I'm going to take the 2, multiply it times 7. That's going to get us 14. 2 times negative 3 is going to be negative 6. And 2 times negative 8 is going to get us negative 16. Now I'm going to go ahead and add. That's going to get us 26x. Here, that's going to cancel out and be 0. And here I get 26. And now I'm just going to simply divide by 26 here. X is equal to 1. And take my 1 and plug it in. I just happen to pick the first one here. So I have 4 times 1 plus 2y is equal to 14. Four times 1 is going to get us 4 plus 2y is equal to 14. Now subtract the 4 on both sides. Get 2y is equal to 10. Divide by 2. And y is equal to 5. So now we got our solution here. X is 1 and y is 5. And that's pretty much it. That's solving a system of linear equations with elimination and having to multiply first. I want to thank you for checking out A1 Math, and have a nice day.